Hi everyone, welcome to our notes on 9.5. We're talking about equations and graphs of various functions. So we've talked about a lot of different functions so far this school year. And with each function we've looked at their equation and we've also looked at the graph. And now what we're going to do is we're going to be basically combining all of these functions into one lesson, and we're going to see how quickly and how efficiently we can identify these functions. Such as this first one, I show you a graph and what function comes to your mind. Hopefully the quadratic function. This is a quadratic. The quadratic, they have parabolas or U-shaped graphs. They have two roots. This one has two real roots. It has a minimum or a vertex right there. So all of those properties of this function makes it a quadratic function. Let's look at problem number 2. The end behavior ends in opposite directions, and there's a relative maximum and there's a relative minimum. This is your cubic function. Your cubic function has 3 zeros, and as you can see, it crosses 1, 2, 3 times. So cube means 3, so when it has 3 zeros, that's a cubic function. There's the answer for problem number 2. Number 3, these ones have our vertical and horizontal asymptotes. This is the one that we're studying this chapter. So when we have asymptotes, it means that there's a variable in the denominator, and when we have variables in the denominator, you cannot divide by a 0. Those are called our rational functions. That's what we're studying this chapter. Rational is problem number 3. Problem number 4, our half of a sideways parabola. Those half sideways parabolas, those are our square root function. The square root function starts at a certain value, it goes up and to the right, it's half of a sideways parabola. So there's our square root. This one is the one that we're most familiar with. It's y equals mx plus b. It has a slope, or it has a y-intercept, and then it has a slope of down 1, right 3, so on and so forth. Those are our linear functions. So number 5 is linear. Number 6, this is another quadratic. It's an upside down u, but it's still a quadratic. The only difference is that the a value is negative on this one, but it's quadratic. Number 7, we haven't spent a whole lot of time with this one. This is called our greatest integer function. So when every y value is an integer, as you can see, it's not a slope, it's an integer at each y value. So that's the greatest integer function. That's problem number 7. Problem number 8 is another one that we're studying this chapter. It has an asymptote right here, and when it has an asymptote, that's a rational function. So number 8 is rational. Number 9, the V-shaped graphs, whether it's a upside down V or a right side up V like this one is, these are the absolute value graphs. Absolute value. So there we have the first 9. Why don't you guys pause the video and try the next 9 on your own. Let's see how well you do. This one is just a line, or it's a linear function. Another way you might refer to this one as, other books and other classes might refer to it as the constant function. When it's a horizontal line, it's constantly y equals a negative 3. So it's constantly a negative 3. It has no slope. I will accept either linear or constant on our next chapter test. So you could put either one. Number 10, hopefully you guys put a quadratic. When it forms a parabola, this is a quadratic function. Number 12, this one is maybe a little bit trickier. This is our cubic function. Our cubic function, the end behavior goes in opposite directions, so that's a big one. And you know it's not linear. When it kind of flattens out here a little bit, those are going to be our cubic functions. So that's number 12. Number 13, the v function, or the upside down v, is the absolute value. So that's what you should have for number 13. Number 14 is cubic. Number 15 is our greatest integer. (16) is what we're studying this chapter. It's our rational function. 17 is linear. And 18 is our square root function. So those 18 are all looking at graphs and identifying their functions. Now the next 18 that we're going to do is looking at the equation and identifying the kind of function that it is. So when we do that, notice here, we know it's a linear equation if our degree is 1. So y equals mx plus b, the degree on x is a 1. It's a quadratic when the degree is 2. So y equals x squared, that's a parabola, the degree is 2. When the degree is 3, such as y equals x cubed, you know that the degree is 3, so it's going to be a cubic function. It's always going to be rational if you ever see a variable in the denominator. So if it has a fraction and there's a variable in the denominator, it's got to be rational. And these next two are quite basic, I guess. If you see a square root symbol, it's the square root function. If you see an absolute value symbol, it's going to be the absolute value function. So those two are hopefully dead giveaways. Let's try the first 9 all together, and then you guys try the next 9 on your own. This one, you see a squared term, the degree is 2, so that's going to be a quadratic. Number 2, the degree is 3, so it's going to be cubic. Number 4, here's a fraction with variables in the denominator. That's our rational function. Number 4, you see a square root sign. That's a dead giveaway. It's the square root function. Number 5, it's not written in descending order, so you got to be very careful. That has a degree of 2. It's going to be a quadratic. And then number 6, this is y equals 7, so it forms a line. So if you put a linear function, you could do that. You could also put the constant function because it's going to be constantly 7. There's going to be no slope in that one. Number 7, here we have a fraction with a variable in the denominator. It's going to be rational. Asymptote at x equals 0. Here we have absolute value sign, so that's the absolute value function. And number 9, you see a degree of 3, so that's the cubic function. You guys pause the video, please, and try the next 9 on your own. Number 10, you should have got linear. 12, quadratic. 12 is kind of tricky. The reason why 12 is tricky is because you see a degree of 6. So whenever you get a degree higher than 3, we call these polynomial functions. Poly means many, so many terms, a polynomial function. However, notice how our options are right here. And so actually this one, to be technically right, we would put none listed. It's a polynomial function, but we're going to put none listed. Let's try the next 6. So here we have the absolute value function. Hopefully all of you got that. 14 again is none listed. We would put a polynomial function, but this one, actually the 4th is none listed. This one, 15, is linear. 16 has a fraction with a variable in the denominator. That's our rational function. 17 is linear. Y equals mx plus b. And then 18 is the square root function. So there's a little bit about identifying the type of function it is, either by looking at the graph or by looking at the equation. Let me know if you have any questions on any of those functions when you get to class tomorrow.